Welcome to our video summary of the episode, AI Basics for Beginners from Codebasics. The link to the full episode is listed in the description below. If you find this content a real time saver to explore new ideas, please hit the like button and subscribe for more. AI, machine learning, deep learning, LLMs, agents. If you're feeling lost in a sea of tech jargon, you're not alone. It seems like a new term pops up every day, making it feel impossible to keep up. But what if I told you that all these complex ideas can be understood with simple stories and analogies? The goal is to demystify AI. We're going on a journey from the very beginning to the cutting edge. And by the end of this video, you'll not only understand what these terms mean, but you'll see how they all connect in one big, exciting story. Let's get started. To really grasp AI, we first need a map. Think of artificial intelligence as the whole field of computer science aimed at training computers to do tasks that we humans are naturally good at, like recognizing faces or understanding language. Inside this giant field is a very important subdomain called machine learning. The parts of AI outside of machine learning include older, rule-based systems that don't learn from data, but still help a machine perform intelligent tasks. Within machine learning, we have two main branches: statistical machine learning, which uses classic algorithms, and the one you've definitely heard of, deep learning. Deep learning is all about neural networks. It's the powerhouse behind the current boom in generative AI. It's built on an architecture called the transformer, which is the magic behind tools like ChatGPT. Now that we have our map, let's zoom in. For decades, programming meant giving the computer explicit instructions for everything. If you wanted to classify a spam email, you'd have to write a long list of rules by hand. But what if the computer could figure out the rules for itself? This is the core idea of machine learning. In traditional programming, you give the computer your input and the logic, and it produces an output. In machine learning, you do the opposite. You give it the input and the desired output, and the machine derives the logic for itself. That logic is what we call a model. This allows us to solve two major types of problems. First, classification. Is this email spam or not spam? The answer comes from a short list. Second, regression. What's the estimated price of this house? The answer is a continuous number. But what if you don't have labeled data? That brings us to unsupervised learning. Imagine a child sorting toys. If you give them buckets labeled dolls and cars, that's supervised learning. What if you just give them empty buckets and say, organize these? They might sort them by color or size, finding patterns on their own. That's unsupervised learning, and it's incredibly useful for automatically clustering thousands of business documents. But these methods hit a wall with complex data, which paved the way for deep learning. Statistical machine learning works best with structured data like spreadsheets. When it comes to images or text, it gets tricky. How do you tell a program what a cat looks like? To solve this, we needed an approach inspired by the human brain, deep learning, and neural networks. Imagine a group of students trained to identify a koala. The first row of students are feature detectors. One only looks for koala eyes, another for the nose, another for the ears. They report their findings to the next layer. One student in this layer combines the eyes and nose reports to identify a koala face. Another combines legs and torso to identify a koala body. Finally, they report to one person, the final decision maker, who takes everyone's input and makes the final call. Yes, this is a koala. This team is a neural network. Each student is a neuron. How do they learn? Initially, they just guess. If they're wrong, the error gets passed backward through the network. The final decision maker tells his team, "We got it wrong. Adjust your formulas." They in turn tell their teams, "Pay closer attention." By repeating this with thousands of images, the entire team gets better and better. This brain-like architecture unlocked the ability for AI to not just understand the world, but to create. So far, we've talked about AI that can recognize and classify. But what about AI that can create? That's generative AI. Its purpose isn't to decide if an email is spam. It's to write a new one. This is the technology that powers tools like ChatGPT, which can write a poem, or Sora, which can generate a video from text. The engine behind this is the large language model, or LLM. What is an LLM? Imagine a clever parrot that listens to every conversation in a home. If he hears someone say, "feeling hungry," "I want to have some," He knows the next word is probably cracker, not bicycle. He doesn't understand hunger, but he's a master of statistical probability. A language model is like this parrot. Now, imagine that parrot suddenly gets superpowers and can listen to every book and website on the entire internet. Now, what happens when you give this creative AI the ability to take action? This is agentic AI, where models can autonomously plan, reason, and act to achieve a complex goal. Let's look at an HR chatbot. Level 1 is a simple Q&A bot. We ask about sick leave, and it finds the answer in a PDF. Level 2 is a tool-using bot. You ask how many vacation days you have left. The bot needs a tool. It uses an API to connect to the HR system, look up your record, and give you the answer. Level 3 is the AI agent. You give it a complex goal. Onboard the new intern joining next Monday. The AI agent now creates a multi-step plan on its own. Schedule a welcome meeting. Send an IT ticket. Order a laptop. Create an HR profile. It then uses its tools to execute that plan. It has autonomy. An AI agent is goal-oriented. It plans, and it acts. An agentic AI is a complete system built with these advanced agents to accomplish complex goals. And there you have it. We've journeyed from simple artificial intelligence to the pattern-finding power of machine learning. We saw how deep learning mimics the brain, how generative AI gave machines a creative spark, and how agentic AI is giving them the ability to act on their own. It's not a list of random buzzwords, it's an evolution. Understanding this journey is the key to understanding our future. Let us know in the comments if you find this video helpful or have suggestions for future content. Thanks for watching, and we'll see you in the next one.